Yes, members, good evening. Welcome back to our channel. This is Shaka Anwar, the math tutor. As I promised that I will be always serving you with the best videos. Today, I will talk about the transportation problem. Transportation problem, we want to see how we can find the cost of transferring one commodity from the factory to the supplier or to the factory. Today, we shall just deal with the three formulas we use to find out the transportation problem. And the formulas namely are the northwest corner method, the least cost method, and the Vogel's approximation method. And then we shall see how to optimize the basic solution using the UV approach. Members, now, without wasting any time, let me take you through how we use the northwest corner method as we are solving the transportation problem, and as we shall also see the least waste method and the Vogel's approximation, and lastly we see how to get the basic solution using the UV approach. Okay, members, let me take you through method 1 with an example. Okay. Yes, members, as you see, I have said, we are going to first solve the transportation problem. Now, this is an example of our transportation problem. But recall that transportation problem is always divided into two. Transportation problem has two types. One type is transportation problem. We have a balanced transportation problem, and the second one is unbalanced transportation problem. Unbalanced. Where the balanced transportation problem is always, it's when the demand equals to the supply, and here for unbalanced is when the demand is not equal to the supply. But now, for us this time round, we shall only base on the balanced transportation problem where demand is equal to supply. And whenever you are given any question, first try and see whether the demand is equal to supply. The demand is equal to supply, then it is called a balanced transportation problem. Like now, from our example here, we are given, like the supply side is that the factories are supplying, and then these stores are demanding. Like, Factory 1 is already supplying supplying 250 commodities. Factory 2 is supplying 200 commodities. Supply 3 is supplying 400 commodities. Therefore, this is the rows are the supply side, are the supplies, and the columns are the demand. Like here now, the supply is 250 plus 300 plus 400, which is the same as having 950. The sum of the supply, I'm saying that the supply is 950 by adding 250 plus 300 plus 400, 250. Now, what of the demand? The demand is that these stores are demanding, because now we are storing. We have just an example of a given factory, but it has different stores. Now these stores are demanding. They're demanding 200, 255, 275, and 250. Also, if I add up this, I see that it's the same as having 950. Therefore, our transportation problem is balanced with the supply and demand equal to 950. Therefore, we are able to use our methods of northwest corner method, Vogel's approximation method, and least cost method. Now, I just want to take you through how we explain this graph. I've said that these are the factories. Look at this table. The factories are supplying this amount. They are supplying this amount. But now, these stores are demanding this amount. They are demanding this amount, which is down here. But now, what's the meaning of these values inside the table here? This refers to the cost of me transporting from one commodity, from one type of commodity from factory 1 to store 1. This will be the cost. This 13 is going to be the cost of me transporting the commodity from factory 1 to store 2. What are we making sense? Therefore, this 10 also is going to mean that the cost of me transporting from the factory 2 to store 4. Therefore, we want to see what is going to be the least cost. What's going to be the method for us to determine our transportation problem. Now, if we go in for the northwest corner solution, we shall always determine the northwest corner, and then we deal with that. Like an example, for this table we have here, what's going to be our northwest corner? Like if we try to remember, this is my part I'm interested in. I said these are the costs. Remember, these are the costs I'm interested in. Now, if we try to look here, if I try to sketch my compass in this box, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. My middle part is going to be here. If I try to sketch my northwest, Remember, my compass is like this. Now, northwest is always this side. This is the northwest corner. Therefore, if I try to sketch my compass here, I will let you know that my northwest corner is going to be this northwest corner. This is going to be the northwest corner as this is going to be my northwest corner here. Like if I try to put this compass here, I will say that my northwest corner is going to be this one here. Now, after I know the northwest corner of this bracket here, now I will always choose to, if I have a demand and a supply, therefore I will always choose to first demand the less. Okay, a factory 1 will supply, factory 1 will supply 200, but factory store 1 demands only 200. Therefore, for store 1, we will only consume what it demands. Like I'm saying that factory 1 supplies 250, but store 1 demands 200. Therefore, for store 1, it will only consume what it demands. Therefore, instead of having the 250, therefore I'll just take the 200 here. I said this is 200, I put it here. Now the difference is going to be, if factory 1 supplies the 200 here, therefore it will only be left with only the 50. Are we together? I think we're together at that side. Therefore, therefore factory 1 will receive no other supplies from factory 1 and factory 2. Therefore, I have to cross out these two boxes. I'm coming again. I'm saying that factory 1 supplies 250. Store 1 demands 200. Therefore, if factory 1 supplies 250 and store 1 demands 200, therefore, store 1 will only accommodate what it demands. It will demand 200 only, and therefore, it won't get any other supplies from either the factory 2 or factory 3 because it has accomplished its demand. Therefore, I have to cross out these other boxes, and then since I have already the demand of, since factory 1 has already supplied the 200 store 1, therefore it will be left with only 50 units to supply. I think I'm clear on that step. Then for the next step now, I've seen that now this column is gone because I finished this column. Now I'm left with only these other columns: 1, 2, 3, 4, 5, 6, 7, 8, 9. Also, if I try to draw my northwest here into this, I will see that my northwest, if I try to draw in the middle here, this is going to be my northwest. I think this is my northwest. Therefore, I'll just say that my northwest now, my northwest box is going to be, this box, this one, because this is my next northwest corner, my next northwest corner. Therefore, instead of me now, remember now, I'm looking at that factory 1 is supplying. We've said that this is my next northwest corner. This one, because I have killed off this column, I'm left with only 9. Therefore, for this 9, this is going to be my northwest corner. Like for all these 9 boxes, I'm going to be left with only this northwest corner here. Here, you see that I'm going to be left with 0 here. Then here I have 50. Now look at here now. Factory 1 is supplying now 50 only, but store 2 is demanding 250. Now what should we do there? Therefore, the supplies which factory 1 will supply will just go directly we just go directly to store 2. Here we have therefore 50, and then this goes to 0, and then here now I'm going to reduce by 50, which is going to be 175. I'm going to reduce to 250 by 75. It means that store 2, which was demanding the 250, the 225. Now, since it has received the 50, therefore its demand is reduced to 175, and factory 1, which supplied the 50, will supply them to store 2. I think we are together. Now, since this one has reduced to 0, therefore factory 1 supplies have gone to store 1 and store 2 only. Therefore, they will be left with nothing to supply to store 3 and store 4. Therefore, if I'm left with nothing, I just put a crosses here. I think I'm trying to explain my thing, and I think I'm trying to get what I'm meaning. Now, shall be left now with these other 6 boxes: 1, 2, 3, 4, 5, 6. Now, also, if I try to draw here my compass, I'll get to know that my northwest corner is going to be directly this box here. If I try to do my compass like this is going to be my northwest corner. Like northwest, if I put this compass here, this is going to be my northwest corner here now. Therefore, what I have to do is me now coming to this box, which is my northwest corner box now again. My new northwest corner box. Now, I compare what is supplied and what is demanded. Like factory 2 will supply 300 units, but now store 2 will only demand 175. Therefore, store 2 will only take what it demands. Like it will take 175 units, and then this store 2 will be left with 0. Therefore, for store 2, it won't be able to demand anything from factory 3. Therefore, also here I cross out this box here. Now, if I remove 175 from 350, therefore this factory 2 will be left with only 125 items for it to supply to different factories. I think we are together. Now from there, I'm left with only 2 boxes. This one, and this one. Now, if I also try to capacity here, minus this one is going to be this box here. Therefore, I'll be able to say that this box of mine here, factory 2 is supplying 125, but store 3 is demanding 275. Therefore, what factory 2 is supplying will be all consumed by now with store 2, which is 125, like this. This now will go to 0 because its supply is accomplished with supplying to store 3. Therefore, if I'm left with 0, therefore there's nothing that will be transferred to store 4. I transfer to this store 4, and then this demand will reduce by 125. Therefore, here I will be left with. If I say 175 divided by 125, I'll be left with 150. I think we are together also that step. Now, missing there now, I'm left with these 2. This one and this one. These 2 boxes here. This one and this one. Now, first one and this one, therefore, the first one is going to be this box here. Now, for it being this box here, if I tried, now, this store 2 is demanding 150 items, but factory 3 is supplying 40 items. Therefore, for me to accomplish the demand of store 2, I'll just give 150 here, and then this one will become 0. Now, if it becomes 0, therefore, the factory here will supply something like 400 minus 150, so it will be the 250. I think we are together. Like, if factory 3 supplies 400 and has supplied 150 to store 3, therefore it will be left with 250 items on the supply side. Therefore, we are saying that on this left box we shall only have the 250 like this for 250. Let's 250. Therefore, store 4 will demand 250 items, and then store 3, which is left with 250 items, will supply the remaining to store 4, and therefore shall have a 0 here, then have a 0 here. Okay, as I've been doing, that everything has to be balancing as I've been doing. I should at the end all have 0 zeros in every row and every sub column. I think I've tried to explain everything here. In a simpler way, for a northwest corner solution, if I'm given 4 demand sides, like 4 stores and 3 factories, just a need of moving like this, like the way you've seen. I'm moving like this, then move down like this, then come like this, then move down, then move like this. You're seeing the method how I'm moving. I'm moving from here to here, then 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 from here to here. But that is only when we are given 4 stores and 3 factories. Therefore, my transportation problem is going to be equal to, like, it's going to be the same as having equals to. Now, the cost of transporting the 200 items is going to be 11. It's going to be 11 times the 200. Yes, now plus 13 times 50. Then now plus 18 times 175. Then now plus 14 times 125 times 125, and not lastly, second but not least, is plus 13 into 150. Now lastly plus 10 into 250, and then this is going to be our transportation problem. Like, the cost of us transporting commodities to store 1, store 2, and store 3 from factories 1, 2, and 3. And therefore, from there, I think we shall be able to get the answers using our calculator. As we say that, it's going to be 11 into 200 plus 13 into 50. It is 13 into 50. Then plus 180 into 175. Then plus 14 into 125. Then plus 13 into 150. Then plus 10 into 250. Like that, then you shall be able to get the cost of us transporting commodities from factory 1 to factory 2 to factory 3 using the northwest corner method. I think members have tried to explain, and this is going to be your answer. I think 12050. Now this is going to be your cost of transporting commodities from factory 1 to factory 2 and factory 3 to store 1, store 2, and store 3. Now members, let us quickly go through also how to find the transportation problem using the least cost approach. This is the northwest corner method. As I've said, that draw your compass, locate your northwest corner box, and as I've asked at the start, you draw our compass like this, but our northwest corner box is this one. Now, after getting the northwest corner box, now try to see which row or which column cancels out. Then also again, draw your compass, check the next northwest corner box or northwest corner box. Then also allocate whether the demand or the supply side according to what the store demands or supplies, and then as I have done, you'll be able to get and allocate the transportation cost of transporting commodities from factory 1, factory 2, and factory 3 to store 1, store 2, and store 3. Now, members, let me take you through how to now solve the transportation problem using the least cost approach. Yes, members, let us continue to see our transportation problem now using the least cost method. Now the difference between the northwest corner, have you seen that in the northwest corner we are looking at the northwest corner box, like northwest corner box, and then we start from there. Now for this method, we shall always now look for the least cost. As I told you that these values inside the boxes here are the cost. Like 3 is the cost of transporting. Yes, 3 of transporting commodities from factory 1 to store 1. This 5 is the cost of transporting commodities from factory 2 to store 3. And then these are the supplies that factories 1, 2, and 3 supply. They are the row totals this side. And then these are the demands that store 1, store 2, and store 3 demand, the column totals. Now we say that we are always working upon the balanced transportation problem, and where the demand equal to supply. Therefore, if you add our demand, it has to be the same as the supply. Everything has to give us this value. Like 300 plus 400 is 900 plus 300 plus 400 is 700 plus 500 is 1,200. Likewise, as you add the demand have to get this value here. Now for the least cost method, note the following, that shall always first of all shall always look for. Shall always, number 1, say we look for the least cost. Look for the least cost. Yes, that's not number 1. Number 2, now if the costs are equal, like if we have 2 equal costs, if the costs are equal, now we look for one with the higher demand. Go with one with the higher demand. Am I making sense for what I'm saying? I'm saying that we shall always first look for the least cost. Like we look around these values, which value has the least cost, and then now if we find that the least cost are some 2 or 3 values, we shall always now look for. We shall always consider first the one with the least demand. Okay. Now let us go through and see how we go about this. Now for this question now here, it is simple. Like given these values inside here are the costs of transporting commodities from a given factory to a given store. Now if I look at every value here, the least cost could be 1, because I'm seeing 3, 1, 7, 2. The least cost is going to be 1. Therefore, I'll always start with the 1, because the 1 gives me the least cost of transporting a given commodities from factory 1 to store 2. Therefore, if I begin with 1 as my least cost, therefore I will be here until 1 is factory 1 is supplying 300 and store 1 is demanding 350. Therefore, I will be able to first supply the 300 to all to S1 because the demand is 300. I have a 300 here, and then this one will go to 0. Then here I'll be left with only 50. I think we're together now. Now, since I have a 0 here, that means that F1 will supply nothing to factory 1, factory 1, factory. Sorry, will supply nothing to store 1, store 3, and store 4. That's why I cancel out these stores, because factory 1 has nothing to supply to these other factories, because all it supplied it to store 2. Now from there, we also now come again. Now we look at these remaining values. Which value is the smallest cost? Like the smallest cost. Now if I look around, I'm seeing the 2 and the 2, which are the smallest costs now. Now there shall always depend on which cost has the highest demand. Now among these 2 and these 2, which has the highest demand? This 2 has a demand of 250, and then this 2 has a demand of 200. Therefore, I'll be able to go with this 2 because it has the highest demand as my node number 2. Therefore, for this factory 2, it supplies 400, but factory 1 only demands 250. Therefore, I'll supply the 250 to store 1, 250 to store 1 because demand is 250, and then nothing will be demanded by store 1. Therefore, I'll be left with 0. And then now here, of the total supplies of the 400, if I supply the 250 to store 1, therefore I'll be left with only 150 supply on 125. Sorry, 150. Yes, 150 supplies only. That into factory 2 will be left with only supply at 150. But to where? That is the question. Now, since this one has gone to 0, therefore supply 1 has already accomplished its demand. Sorry, store 1 has already accomplished its demand. Therefore, it will obtain nothing from factory 3. That's why I need to cross out this row for factory 1 and yes, for factory 3 and store 1. Now, if we come back to now these other values left here, we are saying that the least value is what will be these 2 now. Since the least value is 2, which is the least cost, then I go with that 2. Then here I'll be able to say that since factory 3 is supplying 500 items, but store 4 is demanding only 200. Therefore, I will supply the 200 first to this store as 4, and then here I will be left with 0. Me being left with 0, it means that I will have nothing to okay, store 4 will receive its own supplies from factory 3, and therefore it will receive nothing from factory 3. Since factory 3 now has supplied the 200 to this one, therefore you will be left with only 300 supplies. I think we are together. Yes, I think I'm going slowly. Now we are left with only these values here. We have 6533. Now the least cost is 3, but 3 are twice. Now what should I do there? Now I go with the supply. Okay, with the cost with the highest demand. Now this 3 and this 3, this 3 has a demand of 400, this 3 has a demand of 500. Therefore, I should go first with the supply with the highest demand of 400. Therefore, I'm going with the 400 here. Yes, I'm saying that these 3 and 3 have the demand of 400 and 500. As we said that from our note that we shall always go with the value which has with the cost which has the highest demand. Now on 500 and 400, which is bigger, 400 is bigger, therefore I'll go with these 3 first. But now these 3 saying that store 2 demands 400, but factory 3 only supplies now has only 300 to supply. Therefore, it will supply what it has to this factory, to this store 3, the 300, and then this store 3 will be left with will be left demanding the 100, and therefore this will go to 0. Now, if this one goes to 0, therefore it means that store 3 will have nothing to supply to store 2. That's why we cross out this store 2. I think I'm making sense. Yes, I'm making sense. Now, likewise, we shall be left with only 2 values now. This 6 and 5. Now, what do I do there? For 6 and 5, I'm saying that for 6 and 5 now, what's the least cost? The least cost is going to be 5. But now, if I come to this 5 down here, I'm saying that factory 2 is supplying 150, but store 3 is only demanding 100. Now what should I do? That the out of the 150 factor 2 is supplying, it will only give store 3 only 100. Therefore, I'll just put here that it's going to give this one 100. Therefore, this one goes to 0. Now, if it goes to 0, therefore, this one is going to be left with only 50. Factor 2, if it supplies 150 and it gives 100 to store 5, therefore, it is going to be left with only 50. And therefore, this 6 which is left is going to be left with the 50, and then here's going to be the 50 again here. Therefore, this 50 will go with this 50. And I think by that time, we shall be having a complete transportation problem using the least cost approach. And what you have to note every time is that if you add the aggregated cells you've selected, like here I've selected these 2 and 250, it should give the demand which is here, like 2 is demanding 250, the 250 is the demand here, like only the aggregated cell is 250, then I have the 250 here as my initial demand. Also here, if I have 350, if I add these 2, I have to have 350. Also here, if I add 300 and 100, I have to add the 400 I had here before. And here, if I had 200, I have 200 here also. Then that is making sense that for every column, I should have the same amount of the demand I had, and then for every row, I should have the same amount of demand I had here before. If I add the aggregated cells, like here, if I add like 300, so the demand I had here. Yeah, if I add 250 plus 50 plus 100, I have 400 here. If I add the 300 plus 100, I have to have the 500 here I had here before. And therefore, this is the way we solve for the least cost approach. Now, I want to make this clear, and you should note about it that I should always look for the least cost first. If I get the least cost, therefore I'll bring that least cost. I said that the values inside here are giving us the cost of transporting a matrix from transporting a commodity from factor 1 to factor 2. Now, from there, we shall be able to also, now if I find that the factories are equal, like let's say the costs are equal for transporting the commodity from a commodity from given factory to given store, then I should choose the cost which has the bigger or the higher demand. And therefore, from here, I just conclude that my cost of transporting the commodity is just like equals to, going to be now equal to, I look now for related sales, 1 times 300, yes, now plus, it's going to be 2 into 250, now plus 6 into 50, now plus 5 into 100, now plus again 3 into 300, now plus 2 into 200. And then this cost is going to be, this answer I get here is going to be the cost of me transporting the commodities from a given factory to a given store using the least cost approach. And I think if I add, I'll be able to get the answer. 300 times 1 plus 2 into 250, plus 6 into 50, plus 5 into 100, plus 3 into 300, then plus 2 into 200, we're able to give me the answer, the cost of transporting my commodities from factory F1, from given factory to a given store, which is going to be 2900. Then this is going to be my cost using the least cost approach of determining transportation problem. Yes, members, now I think for this thing is easy, and you have seen how we do it. Now, allow me to take you through on how we solve the transportation problem using the Vogel approximation method. Yes, members, now let us go straightly to Vogel approximation approach. Now, for Vogel approximation approach, we shall need to just know that, okay, yes, a disclaimer is that these different formulas we are using, okay, give different answers to different, okay. If you use a different approach, you have a different answer. Therefore, don't worry if you get a different answer using a different approach. Now, today, let us talk about the Vogel approximation approach, but you said that the first thing you have to first check, whether the demand is equal to supply. And then if you add these things, so that if you add everything, you have get 1.5. Now, for this method of Vogel approximation approach, we shall need to first find the difference between the two smallest values, the two smallest costs into our row and our column respectively. I'm saying that what I have to do, I have to create a row, like a row here for a difference, and a column here for the difference between my two smallest values into a given row and a given column. Like here, you're saying that here I have 3, 10, 7, and 4. Now the difference between my two list values is going to be 3. Okay, my two list cost values in this row is going to be 4 and 3. Therefore, what I have to do is multiply the difference between those two list cost values into the column, and then 4 minus 3 is going to be equal to 1. Yes. Now also I need to get the list cost. The two values of that give me the list cost is going to be 2 and 5. Yes, these values are giving me the list cost because these are the list values into here. Now I get that difference. The difference is 5 minus 2, so to be equal to 3. Yes, and then for this also row, I choose that my list values is going to be 3 and 2. I want to be the list values. The difference is going to be 1. Yes, yes. Now also I come for this now given column. What's going to be the list value of these two values? It's going to be 4 and 2. Going to be my two list values, and the difference is going to be a 2. Now for also here 7, 5 and 3, my list values are going to be 5 and 7 and 5 and 3, and then my list difference is going to be a what? The list difference. The list costs are going to be 5 and 3. Now the difference is going to be a 2. Now also here, if we check 10, 6, and 3, these two values are going to be the list two values, and then the difference is going to be a 3. And then lastly, if I check here 3, 2, and 8, the list value is going to be 2 and 3, and the difference is going to be 1. Now note, what you have to note first is you have to note that now we shall always go. What you have to note that we shall always choose the row or column with shall always choose the row or column with the what? With the highest difference. We shall choose the column or row with the highest difference. Yes. Now, if the differences are the same, like if the highest differences are the same, what should we do? Now we shall choose arbitrarily. We shall just choose anyone. We shall just choose any. Just choose any, like we choose any to start with. We may choose a given row, a given column with the highest. If the biggest difference are the same for a given row, for a given column, we just choose any to begin with. Now we come back now. For example, here I'm saying that for this row, the biggest difference is going to be a 3, and then for this column, the difference is going to be a 3. Now between this 3 and then this 4, I choose any I want. Now, me personally, if I choose this 3 to be my answer, yes, I have said that we choose arbitrarily. Therefore, I will need to choose between this 3 and this 3. Now, if I choose that 3, I begin with this 3. Therefore, I'll come into my matrix here. This row, I choose the least cost, which is going to be a 2. Therefore, I'll just come here. I said the least cost in this row is going to be this 2. Then I come here on this 2. Now, on this 2, I'll check the demand and the supply. If the demand is less than the supply, I'll just go with the demand. Therefore, here I'll just put here the 250. Then this goes to 0. Therefore, this goes to, I cross out these other two. Therefore, here I'll be left with only 150. Yes. Now, me left with 150. Therefore, it calls me now to go for the other difference. Like then this row is cancelled out because store 1 will only demand for 250 items. Therefore, it will demand nothing from factory 1, demand nothing from factory 2. That's why I cross out this given column. Now, if I go for the second difference, like what is left? I'm going for the second difference. Like now I'm left with only 1, 2, 3, 1, 2, 3, 1, 2, 3. Again, now look for the difference. Like now between 10, 7, and 4, the list is going to be 7 and 4. Therefore, the difference is going to be 3 here up again. Now for this one, it's going to be 5. This difference is going to be 1 between 5 and 6. It's going to be 1. Now here, this difference is going to be what? 3. Going to be 3 and 2 is going to be 1 again. Now, if you come down here, shall have the same values. Here is going to be 2. Then here is going to be again 2. Here we shall have, I think, a 3. As I said, I will always choose a column or a row with the highest difference, and the highest difference of mine is now 3 and a 3. I said if the 3s are the same, I just choose arbitrarily. Now again, I'm going to choose this row which has a 3. You may try to choose this one, or may just choose this one, but for now I've chosen this one. You just choose arbitrarily according to the value of R you've got. Now from there, if I choose this 3, then I'll come inside into this row of 3. I choose which value of R to take, like which value of, yes, which value, okay, sorry, what is the smallest value inside here to go with first. Now if I look at 10, 7, and 4, this 4 is the least cost, therefore I'll take the least cost, which is 4. Then I come here, I say, if I'm there, what do I say? I'll say that this is the 4, but this factory 1 is supplying 300 and store 4 is demanding 200. Therefore, I'll put the what store 4 demands, which is the 200 here. Then here I'll be left with 0. And here I'll be left with 100. And then I cross this out with these other 2 cells because supply of factory 4 is only 200 and it has already got it from factory 1. Now from there, I'll also need to also do another column of the differences for the left cells and rows. Now for here, if you see properly, we are just left with 2 values: this one and this one, this one and this one, this one and this one. Now here, now what's the difference between 10 and 7? Is going to be exactly 3. Now what's the difference between 5 and 6 and 5? Is going to be what? 5 and 6 is going to be 1. Now what's the difference between 3 and 3? Is going to be 0. Now what's the difference between 7 and 5 and 3? Is going to be a 2. The difference between 7, 3, and the difference is going to be also 3. Now also again here, I'm saying that these 3s are what? Are common. Then if I choose again these 3 of this column here, I'm saying I choose arbitrarily. If they are the same, I just choose any of them. What do I do? If I come here now, I choose between 10 and 7, which is the biggest. 10 and 7, 7 is the smallest cost, therefore I go with the smallest cost. Then I come here, I've said this is my smallest cost. Yes. Now if the smallest cost, factory 1 is supplying 100, factory 3 is demanding 400. Therefore, I'll supply the 100 I have to here. Then here I'll be left with 0, and then I cancel out this. Then here I'll be left with only 300. Therefore, tower 3 will be left with a demand of 300. Therefore, now if you see now, we have only left with 4 boxes: 1, 2, 3, and 4. Again, I'll need to draw my other column of the difference between what is left. Like now, what is left here? I'm left with 5 and 6. The difference is 1, and the difference here is 0. Now for here, the difference is 5 and 3. The difference is 2. Now for here, the difference is what? 3. Then I'm seeing now the difference here of 3 is the biggest. Now if the difference of 3 is the biggest, then therefore I'll need to go with the difference of 3, because this is the biggest. Now then I'll choose this difference of 3. What is the biggest? Between 2, 1, and 0. Now, if this is the biggest, now I'll come now. I see among the 6 and 3. What is the smallest value? What is the smallest cost? The smallest cost is going to be 3. Therefore, I need to go with this 3. Now, if I go with the 3, I want to look at the 350 supply. So the demand which S2 has and the supply of 500 which also the 3 supplies, and then I will go with the 350. Then here I will be left with 0. Then here I will be left with 150. Now from there, it will need me to cancel out this column, this 6 here, because now factory store 2, its demand is accomplished by factory 3, giving it 350 items. Yes. And now we are left with only 2 values. We are left with 5 and 3. Now for that case, now I just need to just use logic, and we see how we can get the answer there. But now between 5 and 3, I'm saying that this 3 is the smallest. Therefore, I first go with the 3 with the least cost, and then I put here. Now I say between the 300 and the 150, what is big? The big is 300. Then I'll just put here 150 here. Then here I'll be left with 0, and then here I'll be left with 150. Now, me being left 150 here, therefore I'll have to put 150, which is left here, so that I balanced my problem. And then this is 150, and then 150 is going to become 0, and then this one becomes 0 again. And therefore, these cells I've selected, these are the allocated cells, and then there are the cells that will give me the least cost using Vogel approximation approach method. What you have to note is that I need to first have a difference between the two least cost values in the given row and the given column. Then I will choose the biggest difference, and if the biggest difference are the same, okay, if I have like two or more values which have the same difference, like 3 and 3, then I will choose any 3 by any approach. I just choose arbitrarily, just choose any 3, and then I'll have this solution as you've seen. And just note that these different formulas give us different solutions, but all of them are right according to the formula you've used. Now, members, now from here, I think we can only now get our solution. Like our solution is going to be like now. It's going to be our equals to now 7 times 100 plus 4 times 200. Yes. Now plus I have 2 into 250. Yes. Now plus 5 into 150. Now plus what? Plus 3 into 350, and then plus 3 into 150. Now by getting this answer, we'll get me the cost, the transaction cost of transporting commodities from a given factory to a given store, and then it's going to be 7 into 100 plus 4 into 200 plus 2 into 250 plus 5 into 150 plus 3 into 350, then plus 3 into 150. Then the answer is going to be 4250. Then this is going to be the cost of us transporting the commodities from different factories to given stores, as I have explained. And I think, members, this is the best thing you can do right now, and I think I've been trying to explain everything. Now your task is doing what? Is doing a lot of questions and become superior like me. If you are able to do a lot of questions, you'll be able to see how these values differently change with different solutions, and you see that different methods give you different answers, and which is fine. For any questions, just remember to hit my comment section. I'll be able to answer you, and then also remember to WhatsApp me for any questions. I think I shared my number last time. Let me also share it now. My number now is 07009814 and then 68. Just feel free to WhatsApp me. I'll be able to answer your questions and then clarify more where you are lost. Yes, now for the last part, I think now we want to see how we apply the optimization of the UV approach. So the optimization of the solution using the UV approach. Okay, members, thank you for watching. I think for the next video, we shall be able to see how we optimize the solution using the UV approach.